Right, guys, I'm back. Let's get started. First of all, a warm welcome. I am Abhinandan Panigrahi. I'm a co-founder at Edyst, and today we're going to do one of the more recent CodeVita problems. Pretty simple, as in the problem description is pretty simple. Test cases again not too tricky, but the way you take in input and output, especially the way you take in input is kind of the hardest part of this problem. So if anything, that should tell you that it's an easy question to solve, right? We should be targeting to get questions like this in CodeVita. They might take a little bit of time for you to implement. Ideally, I'd say something like this you can probably get done in an hour and a half max. All right, but this is one of the questions that you for sure should be able to solve in the CodeVita setting, right? Um, so let's get to it. I've prepared a couple of slides for us to go through, especially when it comes to looking at test cases. So hopefully you'll end up liking that as well. Let's go through the question first. All right. So here you go. Just gonna zoom in a little bit. Yeah, see, that's good enough for you. So we're going to look at string rotation. So simple problem statement says rotate a given string in the specified direction by the specified magnitude. All right, so that probably means they're going to give us a string. They're going to say, oh, rotate left by 3, rotate left by 5. Keep building the story in your head as you read the question. All right, after each rotation, make a note of the first character of the rotated string. All right, after all the rotations are performed, the accumulated first characters, as noted before, after every rotation, that is, all these accumulated characters are going to form another string. All right, so after the first rotation, maybe the first character was F. After the second rotation, it was I. After the third rotation, the first character of the string remains to be R, so on and so forth. Then it says check if the accumulated first characters is an anagram of any substring of the original string. Okay, so for people who are not that well versed with the following terms, okay, I'm just going to define them briefly. An anagram is something that two strings are anagrams of each other if they contain the same number of characters, okay, and the same type of characters. So for instance, ABC is an anagram of CBA. All right, but ABC is not an anagram of, say, ABCD. All right, because ABCD again has 4 letters, ABC has 3, so they have to match equally, and the lengths of the string should match, and they both should contain the same characters. They can be in different orders, however. Okay, so basically, if you can take a string, rearrange the characters to make the second string, then both the strings are anagrams of each other. What exactly is a substring of an original string? So suppose your string is called first char string. Okay, if you're following me on the web here, so first is a substring. Okay, char is a substring, stch is a substring. Okay, but suppose rthrt, it's not a substring. Okay, substring has to fit somewhere inside the string, but all the characters have to come one after the other. Okay, so you have irst as a substring, so on and so forth. Okay, I'm sure most of you know the definitions. This is just for the benefit of people who might not have come across string questions before. All right, so again, just a mental map. We're apparently given a series of rotations. Okay, we can check that by looking at this. So they give us a word, and they're going to tell us all the rotations that we have to perform. So after doing a left rotate 2, a right rotate 2, and a left rotate 3, the first characters from that string after every rotation is going to be RCR apparently. We'll see how that happens. Bear with me for 2 minutes. Now RCR is not an anagram of CARACE, C-A-R-R-A-C-E, car race. Okay, so the reason is there is no 3-letter substring that you can find in this entire thing from which you can make RC and R. Okay, you can't make RCR from the letters here, from any 3-letter substring inside car race. You can't make RCR. Therefore, they're not anagrams and you end up printing no. So with that out of the way, let's go through a couple of test cases. Okay, let's understand what a rotation means here. You just confirm whatever intuition you have by now, and then we look at a couple of test cases, right? So switching over to slides now. All right, so let's go through some simple rotations here. All right, let's go to this one. Suppose your original string is CodeVita. All right, if you do a left rotate by one character, this is what it means. Okay, CodeVita, you're going to take the first character and you're going to put it at the very end. All right, so CodeVita becomes ODVita C. Now suppose you had to do a left rotate 5. Okay, that is kind of like applying L1 5 times. All right, so first your C goes to the back, then O goes to the back, D goes to the back, E goes to the back, and then V goes to the back, right? So after L5 on CodeVita, you will end up at the character I, all right, as the first letter of your thing. We'll get to that in a bit again. Let's look at the right rotation quickly. So again, the string for you is CodeVita. If you perform a right rotation on it by one character, this is what happens. You're going to take the rightmost character and you're going to append it to the front. Alright, this is a right rotation. Seems fairly simple. I mean, pretty much what you had in mind as well, right? So let's go on to a sample case. Remember the car race word that was given in our test case? Which is going to add another extra rotation to it, okay, just so that we are completely clear about the way this thing works. So let's look at it. So it does a left rotate of 2 of the word car race. So you have C and A that come at the very end. The first letter is R. Then you do a right rotate on the string, which makes it car race again. Alright, so you shifted it left by 2, then you rotated it right by 2 again, which means you would have ended up at the original word, right? Then you do a left rotate by 3. So again, you go to race car. Alright, CAR goes all the way at the very end. And then you do a right rotate by 6. Alright, which gives you this string. Now the question tells us to accumulate all of these first characters. When you do that, this is what you have. Alright, if you look at it carefully, I mean, the slide here, right, it should give you some hints into whether you should actually rotate the string in this question. All right, they don't really want to do anything with the rest of the string. They're just concerned with the first character after rotation. Okay, so does that mean we have to write some big function to rotate a string left or rotate a string right? Possibly not. All right, let's see why that is the case. Why we will not have to write a function to rotate a string. All right, if you look at the letter R that comes here, right, it's word 2. It's at 1 2. So after 2 rotations, so suppose C was at 0, after 2 rotations R is the one that comes to 0, right? So word of 2 becomes R. Then you do a left rotate by 2, right? And that becomes again word of 0 is the first word of that after this rotation. If you do a left by 3, which means CAR, go to the very end, then your first character is again word of, it's this R, right? So it's word of 3, alright? And then you do a right rotate by 6. Now if you notice the pattern here, what I'm doing is every left rotation basically shifts the first character by, L2 shifts the first character by 2. R2 shifts the first character by -2. Alright. So if I do an L2, I end up at word of 2. If I do an R2, I end up at 2 minus 2, 0. Alright. If I do an L3, then I end up at 0 plus 3. And if I do an R6, I end up at -3. Now -3 is not exactly weird, okay? All it says is that this is the third character from the end, alright? If you take this string and you rotate it to the right by 6 times, 6 times if you rotate it to the right, then you will end up with a string where the first character is the third last character of the original string. Okay, again, it might be a little too much for you to digest. Just look at this slide for a couple of seconds. Every time I do a left rotation by some amount, my current first, so before I do any rotations, right, my current first character in this original string is 0. After I do a left rotation by 2, my current first character becomes word of 2. Then I do a right rotate by 2, which means it goes back again. The first character of the current string becomes C. Then I do 1, 2, 3, right? Word of 3. And then I do 1, 2, 3, 4, 5, 6, right? I do a right rotate by 6, which means this is the third last character from the end. I mean, it's the third last character, right? So this actually makes life pretty simple for us. So if you now understand how to take care of the rotations, all right, given the string, since the question does not want anything to do with the rest of the rotated string, all they are wanting you to track is the first character. All right, that is why our life gets very simple. We don't have to write a complete function that does, that actually reverses a string or rotates a string. You don't have to do any of that. You just have to keep track of the first character. Now the question doesn't end there, right? So it says keep a track of the first characters. This string RCRA, check if it is an anagram of any substring inside the original string. Okay, again, lot of words. Simply what this means is, can you find a 4-letter window somewhere here? So CARR, ARRA, RRAC, RACE. Alright, those are the only 4 substrings of length 4 that you can make here, right? No rotations allowed, nothing. The question simply asks, out of these 4-letter substrings, is there any substring that you can arrange, that you can fiddle with, so that it becomes RCRA? Alright, it's pretty simple. It's so if you were to, if you've been paying attention now, what you'd realize is the very first substring, okay, the very first 4-letter substring CARR is the one that you can rearrange, so you can make it RCRA. Alright, so this and this are anagrams of each other, and in such a case you have to print yes. Alright, that's about it for the question. Let's take another sample case so that we'll wrap up this discussion. All it changes is, instead of an R6 we do an R5. Alright, again, a left rotate by 2 brings you to RRACECA. Word of 2 is again the first character. Then you increment that by 1, so now the current character becomes word of 3. Then you again increment it by 1, current character becomes word of 4, and then you back shift it by 5, right? You right shift it by 5. So now 1, 2, 3, 4. Right, just 1 second. So we're here. Oh, hey, okay. Yeah, I messed up. So, second. Right, yeah, this is supposed to be an E, alright? This is not supposed to be an A. So excuse the typo, we'll get it corrected on the uploaded YouTube version. But yeah, this is a typo, alright? So if you backshift it by 5, alright, because you were already at this string, right? So now if you do a back rotate by 5, what that means is 1, 2, 3, 4, 5. Now this string is going to come at the front of the rest of it, right? So this becomes ECARRAC, right? That's what's supposed to come here. So ignore this for now. And when that happens, what you'll realize is you get something, the string that you get is RRAE, And if you go through every single window over here, what you'll find is there is no way, there is no window, okay, that you can rearrange to give me RRAE. Alright, so with this particular sequence of rotations, there is no way you can give me RRAE as a substring, as an anagram of a substring here. What's the first substring? Again, CARR, can't do it. ARRA, can't do it. RRAC, cannot do it. RACE, alright? You still can't make RRAE out of that. All right, the big idea that I'm going to leave you with is, again, sample test cases in CodeVita are designed to be small. All right, sometimes they're also designed to trick you into thinking that something is the answer. All right, but again, you have to make your own test cases. All right, you got to spend the first 5 minutes reading the question, making your test cases, and basically setting up your understanding of the problem. Now, once you've done that, I think you'll be in a much. So, if you now start to think about the problem, all right, the big challenges in this question are a, taking input. All right, you've got to take the original word, you've got to take care of all these rotations, right? You've got to take care of a left rotation, right rotation. So the taking the input is a small part of the challenge. But after that, the bigger challenge here is possibly, how would you check if something is an anagram of the other? Okay. Again, I told you before, the clue is in the definition. All right. In an anagram of two strings, they both have to be of the same length, and they both have to have the same number and the same type of characters. Okay, so you should be able to rearrange one string into another. That's an anagram. What it basically means is, if a character appears 5 times in one string, it should appear 5 times in the other string as well. Okay, this is true for each character in both strings. All right, so without further ado, let's try to build let's try to see how you would write code for this. All right, so I'm going to switch over to my editor here. I generally prefer Python. All right, most of you might come from a C++ or a Java background. Trust me, it doesn't change. Okay, it doesn't change much. All you have to take care of is how you pick the inputs. So the part where I take inputs might seem a little confusing to you, but I'm pretty sure you guys know how to do a C in, C out, or a scanner dot next string, scanner dot next int or something, right? So you should be able to map this fairly quickly. All right, so let's begin. Let me see what it is that you would first want to do. Okay, so the first thing that we're going to do is we'll take the word as an input. Take an input, you strip any new line characters out of it. And then what we're going to do is we're going to maintain an array of the first characters. So 1 second, right? So you want to maintain an array of the first characters, which means after every rotation, this is the array in which I'm going to track all of my first characters, right? The next thing that I've got to input apparently is Q. 1 second, right? There you go. So once I've taken the word as an input, I'm going to take Q as an input. Q is just the number of number of test cases here, the number of rotations, my bad. Now for each one of these rotations, I'm going to try and read what the rotations are. So let's just quickly do that. Right, so here again I'm taking an input. Now for every again, so suppose Q is 5, right? So 5 times I'm going to take the line as an input. I'm going to strip it of any new line characters, or there are spaces in the front. I don't want to deal with those. And then I'm going to split them. Okay, so suppose you have L2 as the input, right? Then this input dot strip dot split is going to convert it into an array of two strings, L and 2, right? Now I know that my second the second part, when I split it in a space, I know the second part is always going to be an integer, which is why I have to explicitly convert it here. Okay, I've got to explicitly convert it into an integer. Now after that, what we are going to quickly do is Okay, so once you've set up your direction and your S, alright, so this particular syntax is specific to Python. C++ and Java guys, don't worry, you guys can do it normally. You would have a string called direct or a char called direct, and an integer called S, and then you would just C in direct and S, alright. So C++ guys don't need to worry. Java guys, again, pretty simple for you as well. Now once I have my direction, I'm going to check. So here's what I see, right? Now the intuition that we built was every rotation basically shifts the first character of the string by that much amount. All right, left shifts it by a positive amount and right shifts it back by a negative amount. All right, so what we're going to do is, before we do any rotations, okay, the first character of the string is at index 0, right? You've not performed any rotation, so the first character is at index 0. Now if it was an L rotate, then you're going to update your first character like this. Alright, I do a modulo by length of word, okay, because suppose the word was alright, so suppose your word is square, alright, and you do an L4, you know yeah, let's say you do an L8 on it. Okay, so what that would mean is you want to rotate it 8 times. Okay, so S goes to the back, U goes to the back, so on and so forth. What you realize is after you've rotated it 6 times, okay, it becomes square again, right? So L6 is square, which means those 6 rotations did not count. Okay, so your L8 effectively becomes an L of 2, right? Because if you rotate by anything more than the length of the word, then you basically spent most of your rotation trying to get back to the original word. That, and again, if you do a back rotate, right, if you go in the negative direction, in Python you can always take care of you can do a string of -3, and then it's going to give you the third last character. Not sure if this is possible in C++ or Java. Pretty sure it's so I didn't want to take any chances. Again, I'm doing a mod rotate for the right shift as well. Right. This will ensure that our IDX is always a positive integer. I mean, it's always an integer between 0 and the length of the word itself. Length of the word -1, that is. All right. So now that you're constantly updating your IDX, what you would actually want to do is just append um, the word index to this list of first characters. Right. At the end of this for loop, your first chars, all right, should have a list of characters that were the first characters after each rotation. All right. Now that you have that, all you have to do is you've got to check if it's an anagram of any substring of the original string. Okay. So this is probably a good area for you to try and think of whether you want to continue writing code in the same block. All right, we're already doing too much here. We're already taking input, then we are dealing with the direction stuff here. I personally like to keep my input function really small. Okay, you take all of your input at once and then you give off that input to another function. Okay, your main function, your solve function. Okay, that keeps it clean. I know which part of my code takes care of what just by looking at the function name. So let's make a new function. All right, let's make a new function called let's keep it a really simple name. Let's call it is anagram of substring. Okay, so yeah, let's I mean, it's not a confusing name, I hope. So all it says is if I give you a list of first characters here and I give you the original word, this function is responsible for telling me whether it's an anagram of any substring in word. Okay, so if this returns true, then I'm going to print yes according to the question, and if if the function tells me there is no anagram substring, then I'm just going to print no. All right, so now that I've introduced a new function, let's go ahead and type that out. Right, so let's keep it simple. Is anagram substring. the one thing that we have to check for is, both. I mean, it can't be that your original word is, 5 characters long, but you perform 20 rotations, which means you now have accumulated 20 first characters. Okay, there is no way you can make an anagram out of that. There is no substring in the original string, so the original string has to be big enough. That is what this piece of code is checking. Okay, you're going to return false if the original string is not big enough to make even a single substring of the length of b. So once you've done that, again, I'm just going to quickly give you an idea of what we're going to do here. Again, now what I would want to do is, now that I have the string a, I want to go through every possible substring of a. Okay, so let's see how we would do that. Python, it's pretty simple. So I'm going to go from I in range 0 to length of a minus length of b plus 1. Okay, and this plus 1 is a small peculiarity relating to Python. What it means is basically, if the first string is, so alright, so this I here, okay, the I represents the start of my substring. Okay, so if you had car race, alright, if, sorry, 1 second, if car race was your actual word, and you wanted to check if RCR is a substring or not, then you would start with the index 0 and get yourself CAR. Right, you would start, then you would go to 1 and then you would go to ARR. For 2 you would go to RRA, again RAC, and then you would have ACE. Right, so 4 3. Right, this is how it's supposed to look for you guys. So I'm just going to comment this out. Alright, so you understand what I'm doing here to make a substring, right? My I is going to fix the start character of my substring. So when it's 0, the start character is C. When it's 4, the start character is A. And this range, or over here is where I extract the window. Okay, window is basically my version of a substring. Okay, so I'm going to say start at the character I and then end at the character, so since we're searching for RCR, end at 3 characters after that. Okay, so every time that I do this, my window updates in this fashion: CAR, ARR, RRA. Alright, so now that you have your substring, the way that you check for an anagram is, if suppose we had some function that gave us the count of characters in a given string. Okay, so some string like ABC, I would want to have a dictionary of sort that tells me, oh, A occurs 1 time, B occurs 1 time, and C occurs 1 time. Alright, if the string was AABC, I would want it to return this. Alright, so basically, if given a string, I would want to return, if you had a AABBC, then this would return 2. So I would ideally want to write another small function over here. Okay, all it does is it's going to take a string and it's going to give me a list of the characters in that string along with how many times those characters have occurred. Okay, so let me quickly write that function up for you. Let's call it get char counts. Okay, get character counts. So yeah, so let's look at this, right? So you're going to do get character counts of a string. I'm going to initialize my counts as an empty dictionary. Dictionary in Python is kind of the same as a map, or so in Java you have hash maps, C++ you have unordered maps. That's pretty much what you want to use here. The keys in a dictionary in Python can be integers or strings or characters, any hashable object. Okay, any hashable value. So what I'm going to do is, for every character in the string S that I take as an input to this function, if the character is not present in the dictionary. Okay, so it's the first time that I'm encountering this character. I'm going to add it to the dictionary and say that the count is 1. But if I already find that character in the dictionary, in my dictionary of counts, then I'm going to increase the count by 1. Alright, this seems like a pretty straightforward, pretty simple loop of sorts. So again, this is what we want as an output from this function. Okay, if I give it a string, this is what I want as an output. So if you can just quickly check and confirm that this is going to do exactly that. Alright, so now that I have a function like get char counts, what I should be doing here is I'll do a count b is equals to, I'm going to get the character counts of my string b here, the one that I'm checking whether I can make an anagram out of it or not. And then I would want to do something like this, right? Get char counts of the window string, right? So at this point I now have the character counts of the original string, okay, and the character count of the windows that this particular function is handling. At every window I get a new character count. Now you can optimize this a little bit. I'll get to that probably at the very end, but for the purpose of this question doesn't really matter. Okay, the strings that will be given are pretty small. If you look at the constraints in the question, just 1 second, let me get there. Yeah, so if you look at the constraints here, they tell us that the length of the original string is less than or equal to 30, and the number of rotations that you're going to make are again less than or equal to 10. So when you do something like that, again, there's no point like hyper optimizing your solution before you write a solution that gets you the correct answers. So we will not spend too much time trying to optimize our get character counts. The thing is, since you're doing a sliding window, okay, and let me just quickly go back so that you can look at what I mean by a sliding window. All right, so suppose this is what we were supposed to search for. Okay, after all the rotations we get RRAA, and we're supposed to see if this is an anagram of some substring here. This would have been my first sliding window, right? And this would have been my second sliding window, so on and so forth. I could get this little window to go to the next one. So RRAC becomes my third sliding window. All right. So every time you do that, what you will come to realize is you don't need to count from the beginning. Okay. Once you've made a count for the first window, you can just update it, because the next window means this character goes out and a new character comes in. The rest of the characters stay the same, right? So that's a possible optimization, but again, we don't want to be doing that as of now. So let's go back to the to our editor. Now that we have both of our counts ready, you have your count B and you have your count window. What we would need to do is, again, so we would want to check if these character counts are equal or not, and if they're equal, we're happy, we're good to go. So something like 1 second. All right, so for every window you're going to keep a count of the number of characters, the type of characters that come in it, and then you're going to want to handle checking whether two dictionaries are the same or not. Okay, if two counts are the same or not, in another function called rCountsEqual. Not a very difficult function to write. Just going to leave that here for you. So if you wanted to do something like that, again, so if you have two dictionaries C1 and C2, okay, each containing the count of characters, in Python the way I would do it is, for every character in this first count dictionary, if that character is not present in C2, okay, if a character in C1 is not present in C2, then these dictionaries are obviously not equal. So in that case I return false. The other case where I return false is if the count of that character is not the same as the count of the character in both. If the count of the character is not the same in both the dictionaries, all right, that is another case where I would want to return false. and for every character, if it exists in C1 and the count is the same in C2, then this for loop is never going to return. Okay, your if condition will never be satisfied. So if you're here, if you're at the return to true part, it means that both of the character counts are equal. Alright, so I like breaking up my functions into these small units, because I know that, under the pressure of a CodeVita, if I had written this entire thing in one big block, then anytime that I go to debug something, I'm always confused about, um, which where could my error lie. Okay, what part of my code can I trust? So when you break your code down into small functions that do exactly one thing, okay, so one function only tests if character counts are equal or not. The other function, just the only responsibility is to give you a list of character counts, a dictionary of character counts, right? So if you break your functions into small units, then you'll find that composing them becomes much easier. Okay, so again, you have a function called rCountsEqual, you have a function called charCounts, you have, anagram of substring. An anagram of substring, all you're doing is taking the char count of B, and then for every sliding window of A, again, you're going to end up taking, one second. So yeah, for every sliding window of A, you're going to create the count, the character count for that sliding window, and then you're going to check if, these counts are equal. If both of the counts are equal, it means that B is an anagram of that substring or that substring window of A. Alright, and in that case you're going to return true. If you come through this entire block, okay, without ever returning, which means no matter what window or what substring you have ended up making, the character counts are never equal. In that case, you know that it's not an anagram of any substring, right? So at the very end of the function, we're just going to return false, right? Because if we reach the end of the function, we know that we haven't done anything. I mean, we haven't found an anagram substring. So this ties in pretty well with our overall main function. Let's just wrap this discussion up with a quick overview of what we did. We took our inputs. We're going to keep the rotation, the first character after each rotation in an array here. The first character is at index 0 before any rotation. We take the directions as inputs here, and if the direction is left, we left shift our first character, and if the direction is right, we right shift our first character. All right, and at each point we're going to, sorry, typo there, and at each point we're going to have your first characters dot append. So we're going to add it to the list of first characters. Now that you have that, you're going to check if this list of characters is an anagram of any substring in the original word. All right, this function's only responsibility is to tell you whether you can make an anagram, whether any substring in word is an anagram of first chars. All right, if that is the case, you print yes, otherwise you print no. Your anagram of substring, again, very simple. We've discussed this multiple times by now. You get the count of the original string, you get the count of each sliding window, and if the counts are equal, you're going to return true. Alright, if the counts are never equal, you return false. Then you write two small helper functions. All that they help you do is to get the character counts, alright, and to check if, given two character counts, are they both equal or not. So let's quickly check on the platform whether this works or not. So I'm going to have to shift to Python mode for this question. Pasted my code here. Let's do a sample run for the right. Okay, all the test cases pass. Again, if you remember, for the sample input car race, after these three rotations, you get RCR. There is no substring that's an anagram of RCR. So fingers crossed, hopefully this works for the rest of the test cases. Yeah, it does. All right. So that's about it. The main takeaways from something like this is that you're going to get easy questions in CodeVita. All right. You're going to make life harder for yourself if you don't follow good coding practices. Okay, which means make sure you indent your code well. Make sure you break it down into different functions. make sure your functions do one thing, one small thing, and that's it. Okay, so that you can test those functions and be absolutely sure that one function at a time you can be sure that your code is correct. Okay, this really helps when you try to debug an implementation heavy question like string rotation. It's easy, it's just a little implementation heavy. All right, so hopefully a couple of other concepts that you would have taken away from here are how to check if two things are anagrams of each other. All right, and this whole concept of a sliding window. All right, remember we did not optimize our get character counts for a sliding window. That's, to me, that's perfectly fine. It's a, the input sizes are not that big. It's just a 30 character string. How many substrings can you make out of it anyway? So substrings of a particular length, how many substrings, knowing that you have to have a substring of a given length, there are not that many substrings that you have to deal with. So for my case, because I just wanted to get this right in the shortest amount of time, this is exactly what I did. Right, guys, I'm done with the discussion. I'd love to open it up for questions in case you have any. If not, we're good to go. You can always find me on the Edyst platform. I'm available to chat as from the people who participated in this webinar. Right then, guys. If you have any queries, reach out to me on chat. We'll be back again later with. So just 1 second.
This someone asked Abhishek Reloaded, can you solve the 2019 CodeVita question 5 and 6? So we didn't get any CodeVita 5 and 6 question.
Oh, okay. So Abhishek asks if I could solve the 2019 questions, CodeVita questions 5 and 6. Thanks for the suggestion. This would definitely, if we can get our hands on the 5th and the 6th question, we'd love to see if we can make a quick webinar out of it in the up and coming days. But yeah, thanks Abhishek. Thanks for your suggestion. I'll pass this on to my team. Any more questions? Again, if you liked the video, if you thought the session was